Good day and welcome to Data Color Academy. My name is Jeff Watts. I'm a Senior Application Specialist with Data Color. And today we'd like to cover another tinting tip, color matching pigment selection best practices. So the agenda for today is pretty simple. We're just going to go over some general best practices for being able to select the right pigments or colorants when matching a color when the color matcher is given multiple formulas to work with. So with color matching pigments, preferred combinations using the maximum amount of inorganic colorants and the minimum amount of organic colorants would be best when matching in a retail environment. When we're speaking about inorganic colorants, we're talking about colorants such as white, red oxide, yellow oxide, and black. These are inorganic colorants or natural colorants that actually come from the ground. So these colorants oftentimes give the lowest cost. They offer the best hide, the least fade, especially when dealing with colors that you're matching for exterior purposes in areas with heavy sunlight, and also the least risk of such thing as lime burn. So some of the properties that we're looking at for these, as far as comparing inorganic to organic colorants, is chemistry for the inorganic colorants is very simple. As I said, a lot of these are taken straight from the ground and are more natural, whereas organic colorants are man-made and complex in their nature. The cost is low for inorganics, where on organic colorants, since they are synthesized, the cost is high. Opacity for inorganic colorants is very high. So where hide is important, especially in retail matching for paint products, it's important to get as opaque as possible with the colorants that you have. Whereas organic colorants often have a very low opacity rate and require either a higher level of TiO2 in your base or a higher level of colorant overall. From a light fastness point of view, light fastness is another way to talk about fade. Um, Inorganic colorants are high in resisting fade, where organic colorants are very low or may burn out when exposed to sunlight for a long period of time. Generally speaking, from a chemical resistance point of view, inorganic colorants are much higher in resisting chemical issues. Where organic colorants, it varies depending on the colorant that you're using. On the other side of the coin, the reason for organic colorants is that they are very bright and very clean and very high in chroma, whereas inorganic colorants tend to be duller and not quite as bright. So there are times, obviously, when you're matching colors where you have to use organic colorants, but if you can avoid them and get a good match with inorganic, you're better off going that route. So the next thing I'd like to touch on is something called complementary shading. And complementary shading is basically mixing colors that are opposite. And when you do this, it tends to dull your final formula. A complementary shade, for example, as you can see here, would be mixing phthalo blue with orange, or green with red, yellow with any blue. This tends to dull the final formula. Also, it makes dull colors from bright colors. Remember what we had said before, whereas when you're looking at organic colorants, you're looking at expensive bright colorants, and mixing them with the complementary colorant means that you may be using two rather expensive colorants to get a very dull end color that you could have achieved by using inorganic colors. So it is a very expensive proposition to do something like this. The other advice that we would pass along is to make sure when you're correcting a formula with the pigments that you have, try to stay within the formula pigments that are given without going outside. A lot of times we'll see folks take something like a green, and the green needs to be redder, so they immediately add a pigment, a red pigment, to the formula that may not have existed before, just in order to move the color in the right direction. It is best in that case, instead of going outside the formula and grabbing a red, to stay within the formula and add the reddest thing possible in order to be able to correct the color. This way, you're not introducing other colorants, and you're not introducing other problems, whether or not the color would look the same under different light sources. The more pigments that you add to a particular formula, the harder it is to duplicate as well. In the end, it's best to follow your company guidelines and your manufacturer guidelines as far as what type of formulas that you should be putting forth and what pigment combinations are best, depending on where the final color is going to be placed and what the final product is that the color is going to be placed in. Remember that manufacturers and color labs can advise you on this to make sure that not only do you get a good color match, but you also get a good formula for the environment that that color is going to be placed in. If you'd like to learn more, please contact us and sign up at Data Color Academy on the web, or follow us on the Data Color blog. I hope this was of value to you. Thank you for your time, and we hope to be hearing from you in the near future.